Okay, we've got two functions here. We've got a parabola that's a happy parabola, and that's q right there because minus 3 in q is right where the turning point is. And then there's an exponential equation, and k is y equals whatever this is, but they tell us here something. They tell us that the asymptote of g, the asymptote of this g is tangent to this turning point. So that means this line right here, y equals whatever this y-intercept here, that's the asymptote of this exponential equation, g. Well, first, write down the equation of the axis of symmetry of the parabola. Well, when you're in turning point form, x is minus 3. That's it. It's minus 3 in q. So x equals minus 3 is your answer. You just have to know how to read off the axis of symmetry from the turning point form of a parabola. Now to determine the equation of f in this form, well, that's a little trickier. We've got the function f, here it is, but we've got 0 and 5, and we've got minus 1 and 0. Now the way I did it, I put in minus 1 for x and 0 for y, and then I got an equation. That's going to be 2, 4a plus q equals 0. Then when y is 5, x is 0. I put that in. I got 9a, 5 and plus q, so I got equation 2. Well, I got two equations here. If I subtract them, I'm going to be able to solve for a. Equation 2 minus equation 1. 9a minus 4a is 5a, and 5 minus 0 is 5. Divide by 5, a must be 1. A must be 1. And if we put 1 in here, 4 times 1 is 4, q must be minus 4. And hey, that makes a lot of sense. Q equals minus 4 even looks right. And that is the asymptote of this exponential equation. And let's see what the next question is here. Oh, determine the equation of f. Well, now that we know that this is minus 4, now that we know that q is minus 4 right here, the y-coordinate right there, we can just go x plus 3 squared, subtract 4, work it out. There's the equation in the form ax squared plus bx plus c. All done.